Hello, geometry students. Mr. Zacek back and better than ever. We're in our last lesson of Unit 8, and we're going to be talking about the law of sines. Now, the law of sines is something that we're going to use in triangles that are not right triangles. So if we know the measure of two angles and the length of a side, angle side angle or angle angle side, or two side lengths and the measure of a non-included obtuse angle, side side angle, then you can find all the other measures of the triangle. So the difference in law of sines versus right triangle trigonometry is this will work in any triangle. So let's read what's in the box here. For any triangle ABC, let the lengths of the sides of the opposite angles, A, B, and C, be A, B, and C respectively. So this is what, earlier in the year we've been talking about the importance of the vertices or capital letters, because the side opposite angle A is called side A, but that's a lowercase letter, and opposite angle B is side B, lowercase letter, and the same thing with C. And then this relationship works that the sine of angle A over side A equals the sine of side angle B over side B equals the sine of angle C over side C. Excuse me. Okay, so now here's why that works. If we have a triangle and we draw the altitude from angle C down to AB, and we label that H, so H you see our height there, and triangle ACD and triangle BCD are right triangles, then the sine of A equals H over B. So the sine of this angle here is the height over B, and the sine of B is H over A. So if we were to go over each of those and we cross multiplied, we get, here's where we are, B times the sine of A over H and A times the sine of B over H. We're just doing the cross product property. What do they both equal? They both equal H. So using substitution, we can set these two things equal to each other. And then if we divide both of them by AB, what happens here? Well, the B's cancel each other out and A's cancel each other out, and we're left with that relationship. Okay. Now, one thing to mention, when given side-side angle, the reason why it doesn't work to prove triangles congruent with an acute angle measure, it is possible that 0, 1, or 2 triangles may be formed with the given information. So that's kind of something called the ambiguous case. We're not going to talk about it in the context of our stuff this year, other than just to mention it now. So let's get into some examples of how do you do this. Let me show you what we're working with here. All right, in triangle ABC, so let's draw some triangle. Okay, ABC. The measure of A is 48. Measure of angle B is 93, and side AC is 15, and we're being asked to find, to the nearest tenth, what is the length of BC. So let's just kind of put in first here these, I'll do it with a different color here. This is going to be side A, this is going to be side B, and this is going to be side C. Now, we can always go ahead and find the third angle if we need to. In this case, we don't need to, because the ratio that we can set up here is that the sine of angle B over side B equals the sine of A over side A. And so now it becomes a matter of substituting in for this. So the sine of 93 over 15 equals the sine of 48 over, instead of A, I'm going to call it BC, because that's what we're being asked to find. So we have a proportion. So the key to using this law of sines is you always have to know one angle and the opposite side. So this angle and the opposite side, that's kind of the key to being able to use this to find a side length. So if we cross multiply, we're going to get BC times the sine of 93 equals 15 times the sine of 48. And I just like to leave it all like this. So I'm going to go ahead and do sine of 93. Here I'm going to divide by that. And then I'm going to put that whole thing into my graphing calculator just as that is. So 15 times the sine of 48 divided by the sine of 93. So if we bring this up here, again, we always want to make sure that your mode is correct, and my mode is in degrees. So what I'm going to do here is I'm going to start off by creating a fraction, and then 15, our trig button, sine of 43, let me just look because I forgot, not 43, 48, okay, divided by the sine of 93, and we get 11.16 for our value. So BC is going to be 11.16 would be 11.2. So we found the length there. All right. So 11.2. Now part B says, what is the length of AB? So we come back over here, and what do we notice? Well, we notice AB, that's this side over here, side C. In order to find that, we're going to need to find this angle over here. So we've got 93 plus 48. 93 plus 48 is 141. And then we do 180 minus 141, and we get 39. So 39 is going to be this angle here. So what I'm going to do now is I'm still going to start off with A and, angle B and side B. So because that's kind of like the key, because we know both pieces of that. So the sine of 93 over 15 equals the sine of 39. And what's opposite 39? Well, opposite 39 is this side C, which is also side AB. Okay, now at this point, the algebra of this is very similar. So it's, AB times the sine of 93 equals 15 times the sine of 39. Then we're going to divide by the sine of 93. Whatever we do to one side, we got to do to the other side. So AB equals, all right, so let's go ahead and plug that in. So it's 15 times the sine of 39 divided by the sine of 93. I'm not going to be all that confident that I can remember that, but we'll try it out. Okay, so start off with the division. 15 times the sine, short-term memory, 39 over the sine of 93. And we get 9.5 to the nearest tenth. So AB would be 9.5. So 9.5 over here. Okay, and so now we found all the sides and all the angles. All right, so for question 1, it was a situation where we needed to find the lengths of the sides. Question 2, we can also go ahead and find the lengths of the angles, and I'll show you how we're going to do that here. So this triangle RST, so I'm just going to draw some triangle RST. It says RT is 11, ST is 18, and the measure of angle R is 120. Okay, so this is clearly not drawn to scale. So what I like to do is, let's just identify, this would be side R, this would be side S, and this would be side T, okay? And again, the key to this, to using the law of sines, is I need to know an angle and then the side opposite. That's going to be kind of our critical piece of information. Okay, so what we're going to set up here is the sine of r over side r equals the sine of s over side s. And we have that information. So we're going to substitute it in here. So we've got the sine of 120 over 18 equals the sine of s over 11. So let's go ahead and do the cross product property. We're going to get 18 times the sine of s equals 11 times the sine of 120. And then we're going to divide by 18. And then we're going to have the sine of s. Well, if we want to just find s at that point, we have to do s is going to equal the inverse sine of 11 times the sine of 120 all divided by 18. Okay. Now again, if you wanted to go ahead and do 11 times the sine of 120 divided by 18 and plug that into your calculator, you can. I'm just going to leave it all though to this point here. All right. So here's what we're going to start off with. So we're going to do trig. We're going to do our inverse sine, and then I'm going to set up a fraction template, and then I got to look because I don't remember. 11 times the sine of 120, so 11 times the sine of 120 divided by 18. So remember that whenever you're going to find an angle, we're always going to be doing the inverse sine, and so we get 31.954. So angle S would be 31.954, and it says to the nearest tenth. So we would round that up. So S would be approximately 32.0 degrees. Okay, so we found that, and that number makes sense. We've got an angle that's 120, so we wouldn't want to have another obtuse angle. That would be a sign we did something incorrectly. Okay, now here are the type of questions that they love to ask on our Regents exam using this kind of information. All right, real popular kind of part 3 question. Good bit of work involved with it. So a ship at sea heads directly toward a cliff on the shoulders, the shoreline. The accompanying diagram shows the top of the cliff D sighted from 2 locations A and B, separated by distance S. If the measure of angle DAC is 30, and the measure of angle DBC is 45, and S is 30 feet, so this distance is 30 feet, okay, what is the height of the cliff to the nearest foot? All right, now let's go ahead and find the other angles to start with. So first of all, these two here form a linear pair. So this angle would be 135, all right? This is a 45 and a 90, so this other angle would be a 45-degree angle. And then 30 and 135 is 165, so this would be a 15-degree angle. So those are our angle measures here that we can find just from linear pairs and knowing that they have to add up to 180. Okay, now what we're going to need to do is we're going to need to start off by finding this side over here, side A, as a starting point, and we're going to use the law of sines. So what we have here is that the sine of 15, now what's opposite 15? That's this 30, equals the sine of 30 over side A. Okay, so just applying the law of sines. So we do the cross product property. A times the sine of 15 equals 30 times the sine of 30. Okay, I'm going to divide by the sine of 15. And I get A equals 30 times the sine of 30 divided by the sine of 15. So here we go. 30 times the sine of 30 divided by, is it the sine? I got to check. Sine of 15. Okay, so the sine of 15 is 57.9555. All right, so 57.9555. All right, so that's this triangle that we have right here. I'm just going to kind of draw this again, and this is 57.9555. And this is a 45-degree angle. All right, and then this is our side H. Now, at this point, you can go ahead and do this as law of sines again, or what we could also do is recognize that this is a right triangle. So now we can do, with our hypotenuse and our opposite, we could just do simple right triangle trigonometry, which is the sine of 45 equals h over 57.9555. Again, it's not at all incorrect to do the law of sines again, but we don't have to. And so this is going to be 57.9555 times the sine of 45. And that will get us, let's see, so that answer times the sine of 45, 40.9808. So that's blue, 40.9808. And what did it say? To the nearest foot. So h is approximately 41 feet, the height of that cliff. Okay. So we had to use the law of sines in one triangle to find out what it is in the other triangle. Okay, so we got one more like this. Again, these questions are a little bit longer and they're complex, but they are ones that get asked quite a bit. Here's Bob on a cruise ship and sights the top of a cliff with an angle of elevation of 18 degrees. The ship then sails 250 feet closer to the base of the cliff, and Bob now sights the top of a cliff with an angle of elevation of 26 degrees. Find the height of the cliff. Okay, so what I like to do in beginning this question is let's find the angles. So if I do 180 minus 26, okay, I get 154, which is going to be this angle here, and that's a linear pair, okay? Now 154 plus 18 is 164, which is 172. So those two add together to be 172. So 180 minus 172 is 8. That's this angle up here, 8 degrees. Now that's important because 8 is opposite that 250 degree side, okay? I'm going to call this side side A, and basically I'm going to kind of do this question like the same way we did the last question. So the sine of 8 degrees over 250 equals the sine of 18 over side A. Okay, so we're going to cross product property. A times the sine of 8 equals 250 times the sine of 18. I'm going to divide by the sine of 8. So A is going to equal 250 times the sine of 18 divided by the sine of 8. All right, so we set up our fraction template. 250 times the sine of, I think it's 18, whoops, divided by the sine of 8. Did I remember those correctly? I did. Okay, hit enter. So 555.095. Okay, so A is 555.095. All right, that's in this triangle here. So in this triangle, 26 degrees, right triangle, 555.095, and now this is X. Okay, so I can do trig, right triangle trig at this point. This is the opposite side, and this is the hypotenuse. So I can just do sine. So the sine of 26 equals X over 555.095. So let's just move the page a little bit. Okay, so cross product, X equals 555.095 times the sine of 26. And that is going to be, let's put it in here, there's our answer, times the sine of 26, and we get 243.337. So 243.337. Okay, and what did they want us to round it to? Find the height of the cliff. Well, it doesn't say. So we found the height of the cliff. Let's leave our answer in that that form right there. Okay, so this is again this is the type of thing that you'll see with these last two, and we've got some practice for you with our assignments and lab things. So a little bit more involved. You got to kind of put multiple things here. It's sort of a good culmination for us here at the end of this unit. So I will see you back in Unit 9. Let's ask and keep on asking questions.